Okay, here we're going to look at a word problem here that is an inequality, and we're just going to apply our process for graphing quadratic inequalities here. So let's look at our situation and then let's pick out some key points. So it says a manila rope used for rappelling down a cliff can safely support a weight W in pounds, provided W is less than or equal to 1,480 times the diameter squared, where D is the diameter in inches of the rope. Graph the inequality and interpret the solution. Okay, so right here, let's immediately look at what information is important. So, can safely support a weight in pounds provided. So the weight needs to be less than or equal to 1,480 times the diameter squared. None of this stuff is important. A manila rope used for rappelling down a cliff can safely support a weight. Okay, that's just all detail that is irrelevant to finding the solution. Okay, D is the diameter of the rope. Okay, that's okay, but this is all we need to know. The weight is less than or equal to 1,480 times the diameter squared. Now, we need to look at what is dependent and what is independent. So, one way to look at this is that the diameter depends on the weight. Is that true? Does the diameter of our rope depend on the weight? No, that's not true. The weight depends on the diameter of the rope. The weight supported is dependent upon the diameter. So when we graph this, we're going to look at a graph. So W becomes our Y value, and the diameter is our X. So when we look at this, we're going to have a graph here where our W is the y-axis and D is the x-axis. Now, if we think about this a little bit, let's look at where our graph is going to be. Now, weight. Can we ever have a negative weight? Are we going to look at situations where we're going to have a negative weight? Never. So we don't even bother with anything down here. What about diameter? D represents the diameter of the rope. Can our diameter ever be negative? No. Our diameter doesn't need to be negative either. So really, when we graph this, all we're going to be looking at is quadrant number 1 here, where we've got weight on the x-axis and diameter on the y-axis. So we're going to start here with the diameter equal to 0 and weight equal to 0. And we're going to look at graphing the inequality and interpreting the solution. So our graph is going to look something like this. Now you're going to need to get the exact values, and again, we can go to Desmos to look at this. So we'll go ahead and look at that in a second. But remember, we're just going to be looking at the quadrant 1 of this equation. So let's go ahead. I'm going to take this off, and let's type that back in here. So weight is less than, so we're looking at 1,480 x squared, I believe. Let's just go ahead and term that 1,480 x squared. Now we're going to want to zoom in here, so I can change the x-axis and y-axis. Let's go from 0 to, for the diameter, we can go from 0, let's just say, to 10. For the y-axis, we're going to want to go from 0 to, I don't know, 10,000 maybe, or even bigger than that. Now look what we have here. This is what we have. As our diameter gets bigger, we're going to see that the weight it supports. So look at, these are each going by 20,000 right here. So we're going to have a pretty big graph. So this goes from 0 to 20,000, 40,000, 60,000, 80,000, and look how our diameter in inches increases. Okay, so this is what you have to think about when you are plotting your graph. If you only did small units here or increments, like 1,000 at a time, that wouldn't make sense. If here you did 10 inches at a time for your increments, you wouldn't be seeing enough of a curve. You have to just use common sense for some of these problems. Okay, so let's go back. Now that we have a good idea of how to represent this, let's go look at our problem here. And remember, we want to look at if a rope can safely support a weight. So we need to think about, are we looking for the area below our line or above our line? Well, just using common sense, we have a good idea. I'll bet you guys all have a good idea of which region we're going to shade right here. But let's just show you guys analytically how you can do this if you're just not sure. So here we go. Here's our inequality right here. Now look, they zoom in even further. They just do units by ½ an inch right here. Okay, now what we can do is we're going to just test a point on this. So the point they pick is the point 1 and 3,000. So again, our line is solid here because it's less than or equal to. So we're going to pick 1 and 3,000 for our point. Now think right now. If the area that we shade, if this point makes this a true statement, that means it lies within the area or the region that we're going to shade. If we plug in this point and we get a false statement, that means it is not in the area we shade. Therefore, we shade the opposite section. So remember, we're kind of just testing this out right now to see what area we shade. We've got two possibilities. We either shade above our line or below our line. And what we're doing is just picking a point, and if it gives us a true statement, we know this is our shaded region. If it gives us a false statement, we know the area below is our region. So we take this, we write our inequality down, we plug in our values. So remember, D is our independent variable, so we plug our X value in there. W is our dependent variable, so we plug in 3,000 for there. We go ahead and work this out, and we get 3,000 is less than or equal to 1,480. That is a false statement. That does not give us a true statement. So we know that this is not our shaded area. That point is not in our shaded area. So we go ahead and shade on the other side. Now again, we know that since we're looking for weights that are less than or equal to this equation, that tells us just by using common sense that this is our shaded region. But to test it out analytically, we can go ahead and pick our point and just plug it in and see if it works. So the way to interpret this is that this shaded region represents all the weights that can be supported by ropes with various diameters. We know that if we pick a rope that has 2-inch diameter, we can support all the weights that are in this area below the parabola.